Welcome back, Mindsetters. I hope you guys have got your pens and pads out and you guys are making sure you're making notes. But also, guys, I want to send a quick and very big shout out to you guys and Happy Youth Day. Guys, enjoy the day, but also remember the history of South Africa. Make sure you guys go and look it up. Make sure you don't just think of it as just a holiday, it's just a random day. No, it's a very important day, June 16th, Youth Day. Make sure you look it up, very important history. And guys, also, I also want to stress, make sure you call in on 0861 058 262. Make sure you need these winter books, because you know why? We're going to be having boot camp very soon. Don't forget, I know you guys have seen the promos, so make sure you stick around with us during those weeks of July, depending on which grade you're in. But make sure, I know I keep saying it a lot, but I need to stress this very much, that you guys are with us for those boot camps, because it's so important. But for now, I'm actually going to hand back to Tamlin. Tamlin, take it away.
Thank you. Right, let's carry on with this question. What we have now done is we have found the angle of theta, we've managed to find the coordinates of point N, and the next question that they are now asking us is to find the midpoint of line BC. Sure to be there, please make sure you know the formula, definitely a possible question in your paper. Right, so we're looking for the midpoint from point B to point C. Again, the formula, it's on your formula sheet, but make sure you know it, okay. Right, let's see, midpoint, the way we work it out is we take x1, we add x2 and we divide by 2, that's to find the x coordinate. And to find the y coordinate, we take y1 plus y2, and again we divide it by 2. Okay, so let's set ourselves up here quickly. Let's write the coordinates. The coordinate of point B is 9 and 9. The coordinates of point C is -3 and -9. Just as a small tip, grade 9s, when you're doing a question like this, sometimes it helps to just take a moment to do exactly what I've done here. Just write the coordinates down, label which one is x1, which one is x2. It's not going to take you more than 15 seconds to do, and it just helps you get your head straight as to which value belongs in which position, okay? Right, so let's do that. This one over here is going to be our x1 and our y1. We've got our x2 and our y2. Okay, to find our midpoint. Okay, x1, which is 9, plus x2, which is -3, and we are going to divide that by 2, and y1, which is 9, plus y2, which is -9, and again we're dividing it by 2. Okay, so let's have a look. We're now going to have 9 minus 3 divided by 2, which is going to be 6 divided by 2, which is going to be 3, and 9 minus 9 is going to land up being 0 divided by 2, and anything where there's nothing divided by 2 is still going to be nothing, so therefore it's going to be 3 and 0. Right, so let's go back to our diagram. The point 3 and 0, if x is 3 and y is 0, is going to be around about there. It's going to be the x-intercept. So we've got the midpoint of 3 and 0. So what we know is that the distance from there to there is going to be equal to, although it doesn't look completely to scale in this picture, we've proven that they are equal in distance. So therefore we're proving that that is the midpoint. Okay. Right, and that is that question. Right, last question over here. We are asked to prove that point A, point N, and point M are what we call collinear. All right. Grade 12s, what collinear means is that they're all sitting on the same line, okay? And the way you prove collinear points is you prove that the gradient from the one point to the next point is the same as the gradient from the next point to the next point, okay? So if we can prove that they've got the same gradients, we are proving that they are collinear. They're sitting on the same line, okay? Right, so that is what our mission over here is going to be. We are going to try and prove that the gradient from point A to point N has got to be the same as the gradient from point N to point M, okay? If we can prove they are the same, Great, they're collinear. If we can't prove they're the same, then we're proving that they're not collinear. Okay, so that's what we've got to try and do. Point A, coordinates of A, let's just quickly write them down again. A was -2 and 7, that was proven earlier. Point N is, point A, that's point N. Let's just rewrite that. Point N is a -2 and 7. Point N is, where's point N again? Point A is point -9 and 12. And point M, which is the one that we've just proven, was 3 and 0. Right, there we go. Okay. Gradients from A to N. Change in Y over change in X. So Y2 minus Y1 over X2 minus X1. Okay. A and N. Y2 minus Y1, so 12 minus 7. Over X2 minus X1, so -1 minus -2. So -9 minus -2. And that's going to leave us with 12 minus 7, that's going to leave us with 5. And -9 plus 2, that's going to leave us with -7. Okay? All right, so that's the gradient from A to N. Let's see if we can find the gradient from N to M. Same story, Y1 minus Y2 over X1 minus X2. Okay, I'm going from N to M. So Y1, let's call that one 0, minus Y2, which is going to be 7, over X1, which is 3, minus X2, which is -2. So 3 minus -2. Okay, we've got -7, and I've got 3 plus 2, which is going to be 5. What have we got here, grade 12s? I've got one gradient that is -5/7, and I've got another gradient which is -7 over 5. So unfortunately, have we managed to prove that they are collinear? No, they're not. So basically, this is the story. If we were to draw a line through point A, through point N, and then through point M, there would not be a straight line through those 3 points, because those 3 points do not give us the same gradient. They are not collinear. Okay. Right, so that's the first question. Everybody understanding? I hope everybody is. And let's have a look at the next question. Okay. That one there. Right, okay. What we've got now is our circle diagrams. Okay. We learnt in grade 11 that when we have got a circle where the center is at the origin, our formula for when the center is at the origin is going to be our x squared plus our y squared, which is equal to our r squared, our radius squared. Just to make it interesting, what we do in grade 12 is we take it from the origin and we push it to a different point. So the center of our circle is no longer going to just be at the origin it's now going to move away. Okay? That then lands up giving us a different formula, and we are going to work with that just now. Right, the first thing that they've told us over here is that in the diagram we've got 2 circles of equal radii. Obviously that's important, so let's just take note of that. We've got equal radii. Okay, and through each point, and point D over there is the coordinates of P and P. The center of the bottom circle is going to be at A, and that lies on the y-axis. This is my y-axis over here. And the other points, and point B lies on the center of the other circle, which is 8 and 7. So let's give ourselves that point over here. Right, 8 and 7. Okay. And the other thing that's been told to us is we've got a tangent. Okay, just to remind you, I'm sure we all remember this from calculus, but your tangent is a straight line that is touching your circle or your other line at just one point. Okay, so this tangent over here is touching both of your circles at your one point. Okay. Right, question number 1 they have asked us over here is to determine the coordinates of point D. Okay. The first thing I would notice with point D is that they've got the same letter. The x coordinate they've told me is P, and the y coordinate they've told me is P. So that should be telling you that the x and the y values are going to be the same. Okay, that's quite a nice little hint there. Okay. What we said right in the beginning is that we have got equal radii. Okay? So if there are equal radii, we should then know that the distances are going to be the same, or we could use midpoints, okay? What we know is we've got this point over here, which is the coordinate of, do we know that? We've got 8 and 7, and it's a common tangent. Do we have all our points over here? Okay, let's have a look. We want point P. It's going to work out to be, we want the equal distance from here to here. So if my distance from, okay, my x coordinate is going to be 8. Okay, so that's sitting over there. So we've managed to move that now. All right, so if that distance over there is 8, this point over here is your midpoint. It's the halfway mark. Okay, which means that on our x-axis, that is going to have to work out to be 4. All right? And this value, we obviously know that the x value and the y value are the same, so as a result, that is also going to work out to be 4. Okay, so by using inspection, because we knew that D was the midpoint of these two lines over here, we could work out that our coordinates of D is going to be 4 and 4. Okay. Right, knowing that, so we now know that D is the coordinates of 4 and 4. All right. They have asked us to prove that, hence show that the equation of the circle with center A is given by the formula x squared plus y squared minus 2y minus 24 equals 0. Okay. Right, our formula for the circle center is going to be x minus x1 squared plus y minus y1 squared, and that's equal to our r squared. Okay, remember that this coordinate over here and that coordinate over there are going to form the circle center, the center points of your circle. Okay, so what are we going to do? We are going to have a look at what we've got over here. I know that this point is now sitting on my circumference, okay? And I know that this point over here has got, I do know what the y coordinate is. I know what the x coordinate is. The x coordinate is 0, but we don't know what the y coordinate is, okay? So what do we know? I've got, into this x1 and into this x2, we can substitute the 0 and the y. We don't know what the y is yet. And what's going to have to be useful over here is we're going to need to work out what that r squared is, the radius. We were told earlier that these two lines were equal in distance. Okay, so if they're equal in distance, I can work out the distance from D to B, and that would then obviously be the same as my radius from A to D. Okay, so let's do that quickly. Let's take our distance from D to B. So dB squared is going to be equal to, let's do our distance formula, x1 minus x2 squared plus y1 minus y2 squared. Okay, our x was 4 and the coordinates of D was 8 and 7. 8 and 7. Okay, so x1 minus x2, let's just do this quickly. 8 minus 4 is going to leave us with 4. That's going to be squared. I've got my y coordinates, which is going to be 7 minus 4, 7, 6 by 4, which is going to be 3. And that is going to be squared. 4 squared is going to be 16. That's going to be 9. I am getting a value of 25, and that is my radius squared. That's my dB squared. Okay, so what I know is that this value over here is therefore going to be 25. Okay, so let's now go ahead and sub into our circle formula. To find the equation of the circle with the center A, we're going to say x minus x1. The circle, the x coordinate of my center, is going to be 0. So we're going to put 0 over here. and that's going to be squared, plus we're going to take y minus, okay, let's call it y2 squared, and that's going to be equal to 25. And while I do all of this working out, I'm going to let Ty just chat to you for a minute.
Okay, no problem. So guys, as I've been saying earlier, guys, make sure you get on the page, keep chatting to me, and call in and win a chance to get these books. But guys, also remember, today is a lot of history. Today is June 16th. Make sure you look it up. Make sure you learn about the whole story about Hector Peterson or the entire Sweater Uprising. And make sure you learn about this. But for now, we're going to see you after this break.